Hello, good evening, and welcome to IoT North. I'm Paul Wheels, founder of IoT North. I'm joined by John Staveley and Jim Bennett this evening. So thank you for joining the July talk. It's going to be a bit interesting. We'll be talking about bears, which is something quite new for us. John, how are you doing?
Very good. Yeah, I've just finished Leeds 12K, and then I also did Total Warrior, gearing up for Castle Howard Triathlon at the end of the month. And then I'm on holiday for August, as is IoT North, just to remind everyone.
So just the most important question then is, how did you track yourself with your 12K?
I use the authorized chip in, chip out, because that's the only thing that matters at the end of the day. Could have used Strava, though. I tend to use Strava for pretty much everything.
Yeah. I've been recommended to use it, but I've never used it yet. Hi, Anthony. Good to have you online tonight. If anybody has any questions, like to say hello or anything, please do drop it into the chat on whichever platform you're using today. We are live on LinkedIn, YouTube, and Twitter. And you can also catch us on our website, iotnorth.uk/events for all previous shows. Let's bring in our guest for this evening, Mr. Bennett, Jim from Azure. How are you, sir?
I'm good. How's it going?
Very good. The sun is finally shining, but it's still windy, and it killed my game of golf yesterday. But apart from that, not too bad.
Nice. We've almost have some sun on the other side of the world. Almost. It's kind of threatening to bring us summer, maybe.
It can't be as bad as Newcastle. Hello from Holland, Michigan. Hi there. Good to have you online. If, as I mentioned, any questions or anything throughout the show, please do ask them, and we'll try and answer them through the show. So, Jim, you were UK, evidently, from the accent. Tell me a little bit about how you've come to tell the story about your bears.
Yeah, so from the UK, not the north part of the UK, the south part. So, but I now live in the Pacific Northwest. So I guess I kind of counts for IoT North, I suppose. You know, in the north part of the US.
IoT North is actually it's the play on words that it started from Newcastle. And then we brought into the fold the Leeds community, the Manchester community, and then we started to branch out across the country. We've got Solent, we've got a couple in London, and we now also have IoT Scotland as well. So IoT North is about giving people a direction in IoT rather than the location of IoT. So it's a little play. It is indeed. It's the North Star to IoT to help people understand the tools and tricks of how they can evolve and scale quickly.
I did not realize that. I like that. So yes, I've been working for Microsoft for almost 5 years now. I was working based out of the UK, but they asked me to move to the mothership. You know, kind of this big pull from Microsoft of please move to our head office. So I upped sticks almost 3 years ago, and then moved to Redmond, which is where the main Microsoft campus is in Washington State, which is, for those who don't know US geography, it's on the West Coast, right at the top. And as Paul was saying, I'm practically Canadian because I'm literally 2.5 hours south of Canada. But if you heard of Seattle,
around the corner.
Yeah. I could pretty much pop over for poutine for dinner and then come home again, you know. But for those who are into things like the grunge scene, you know, bands like Nirvana from Seattle, I am 20 minutes away from Seattle.
Now it makes all sense on the geography on where you are, because I certainly know where Seattle is because I'm going to see Pearl Jam in Hyde Park on Friday with the Pixies.
I'm quite jealous.
Quite good. Yeah. I've seen Pearl Jam a few times. They're phenomenal live. First time for the Pixies though. John, you've shared some links in the chat. Would you like to touch on those?
I bumped into Jim because he does a lot of talks at the Reactor. So I turned up to one of his talks at the Azure Sphere, which is sort of a security offering from Microsoft, which is pretty good. One of these Jim discovers, Jim unboxes type talks, which is great. But Jim's also sort of legendary in the IoT space because he's created this very visual course, IoT for Beginners, that covers everything from connecting to an MQTT broker, security, GPS tracking, geofencing, image classification, and speech recognition on an IoT device. So it's pretty interesting course, very popular.
And it's also free and open source. I will add this. So when we put this together,
GitHub, so just clone it on GitHub, and then you can play with it. It takes you through either on a Seed Studio device or a Raspberry Pi device.
or a virtual hardware. So if you don't actually have to own hardware, we set it up so we've got like a simulator where you can kind of add your sensors and actuators and just write code as if you're writing it for a Raspberry Pi with the seed hardware, but that actually runs against virtual hardware. So you can kind of simulate temperature values and GPS locations and all that. We just want to make it available to everyone. And just the point is, it is free, it's open source, so anyone can take it and do what they like with it. You know,
it's awesome. It says IoT for beginners, but there's some pretty advanced topics covered in the course. Maybe I should go back to school and do some more studying.
Yeah, it dives in quite deep. It very much starts the basics. You know, what is IoT? What is a microcontroller? What are sensors and all that? And then just kind of goes into a lot of these use cases, doing this kind of journey of food from farm to table. So it's kind of all very project based. So you can do some digital agriculture, logistics, manufacturing, retail, and then consumer. So kind of following the journey of food from when you literally grow it right up to the point where you set a smart timer to help you cook your food.
That's really cool. I'm gonna have to check that out. I haven't checked that out.
Yeah, well worth a go.
It will certainly help me because I'm definitely a beginner.
And it's also the month of July OT. Didn't realize that IoT had a month,
July OT, literally the pun of the
events going on like us. We're part of July OT. It's all planned. There's if you share that link, there's a link to some of the Microsoft events that are being run. There's lots of others.
So their comments are in the on YouTube. I'll get it put into LinkedIn, and it's also scrolling across your screen now. I will also, under direction of my employer, because IoT North is nothing to do with Intel. It is all about me. But the opinions shared on this show are personal opinions and not those of the employer of the host, Intel. So there I've done my legal bit for this month. So, Jim, tell us about the talk that you're going to do tonight.
So today I want to talk about tiny machine learning. I want to talk about TinyML and how I can use it to detect bears. So, do you want me to kick off, or do you want to just
kick off, mate? Yeah,
kick off.
Sure.
Okay, if you can get my screen shared. For those who haven't met me in the past, so I'm Jim Bennett. I'm a regional cloud advocate at Microsoft. So it's my job to support the communities in the Pacific Northwest of the US. So if you're based in Washington State, around the Seattle area, and you want to get involved in tech communities, you want a meetup space, anything like that, get in touch, and I'm here to help you. All over the internet, Jim Bob Bennett. So please, everyone, feel free to connect. I'm a friendly chap, so you want to reach out with questions, anything about today, please do. So today I want to talk about, two things I want to talk about. July OT, I know it was mentioned very briefly. So July OT is our whole month celebration of the Internet of Things. And we have julyot.dev is the home of July OT. So if you go to julyot.dev, we have a whole page here with a load of great stuff. We've got what's called a Cloud Skills Challenge, where you can join this and learn about all the Microsoft Cloud tools for IoT and kind of skill yourself up, compete against other people. We've got some cool digital swag. So, if you want a desktop background like mine, called July OT one, we've got that for you. We've got links to all the live streams that we're doing throughout July. We're going to start putting some meetup links up here. We've got some generalized resources around IoT. And most importantly, we have our July OT blog. So kind of every weekday, we are releasing something new about IoT, whether it's a link to something, such as yesterday, I pushed out the link for today, or whether it's full content like getting started with the Nano framework. It's all here at julyot.dev. So head there. And then just keep checking back every day to get more cool IoT content. This is our celebration. It's July. We love July. We love IoT. So keep coming back here every day to get more cool IoT stuff. So that's kind of the big shout out I wanted to do because July is IoT month. But I want to talk about bears. So when I lived in the UK, there wasn't many scary animals. You might get an occasional hedgehog, but nothing really scary. I've moved around the world. I've lived in Hong Kong, where there was, again, nothing particularly scary, maybe a drunken expat. That's kind of about it. Lived in places like Bermuda, where drunken tourist, Thailand wasn't much scary apart from the sudden thunderstorm. But now I live in the Pacific Northwest. I live in the land of bears. And you can just about make out this bear here in the trees. I took this picture I was just popping around to the bins around the side of my house to drop off some rubbish, and saw this bear sitting on my fence, well, half on my fence, half on my apple tree, staring at me. And that was a little bit worrying. We're probably talking maybe 3 meters away, 4 meters away. And so, you know, being a slightly old millennial, I had to get my phone out and take a picture before I walked away very slowly. But bears are here. Where I live, there are bears. Surrounded by woods. Behind my house is woods. Bears are absolutely everywhere. And they do cause a bit of damage. So this particular bear climbed into an apple tree and broke off most of the tree after having a good old feast, and then smashed my fence. It wanted to leave the garden, so it knocked down the fence off into the woods. And so, yeah, little bit of a scary thing having these bears. In theory, the bears won't hurt you unless you threaten their young. But, you know, it's still a bit scary having a bear in your garden. And so I'm kind of thinking, what cool things could I do to detect bears? It'd be nice to know kind of when they come. So how can I do some kind of bear detector? You know, what can I do? Now, there's quite a few IoT projects around wildlife cameras. This is kind of a big thing for IoT projects. You may see a lot of Raspberry Pi type setups with wildlife cameras. You know, these are maybe a camera with a motion detector, ultrasonic distance sensor, something, and then when it detects motion, what it will do is it will start recording video. Or you can use OpenCV to kind of capture video, and if it picks up a change, then it starts recording, things like that. And that's kind of a fairly standard wildlife camera idea. And I kind of have that built into my Ring camera. So out the front of my house, got a Ring camera, you know, standard Amazon Ring doorbell camera thing. And I happened to catch this raccoon the other day. You know, we used to leave a box of snacks out for delivery drivers, but this raccoon decided that it wanted to eat all the snacks. And so, you know, had a good old scoff, left the wrappers everywhere. So now we put a sealed box out for delivery drivers. But yeah, this is quite cool. Yeah, get notification on my Ring app to say, hey, there's movement at 3 o'clock in the morning. You immediately look thinking it's a robber, but no, it's a raccoon. Very cute. But, you know, I have to go and physically look. It'd be really nice if we had some kind of way we could automate this. It'd be nice if I could do something to allow me to be notified when I see a raccoon or a bear and actually know what it is that's in my garden. And so I've kind of been playing with a few toys to do this. And kind of the best way to do this is the idea of Vision AI. So if you've done any artificial intelligence before, there's a whole lot of AI models to do different things. And the particular one is Vision AI. So you can train AI models to use images, videos, and they can recognize what's in these images, recognize what's in the videos, and kind of give you guesses as to what it might see. There's two forms of Vision AI that are kind of quite popular. There's image classification and there's object detection. Now, image classification is where you have an image and it will tell you whether that image is something or something else. Hot dog, not a hot dog. Pizza, burger. Bear, not bear. Yeah, you train up a load of images and say, this image is X, this image is Y, this is Z. And then you give it a new image and it tells you whether it thinks your image is X, Y, or Z, or nothing. And it does it based off a percentage. So it will say, you know, this is a 93% chance this is a bear, or there's only a 17% chance this is a llama, something like that. And it's all based off what's called features. So what it does, it essentially finds different kind of patterns inside the image and uses those through a neural network to work out what that image actually is. You can kind of think of it a little bit. If you ever had, if you've got kids, young kids, and you have those shapes books. So you know, this is a triangle, this is a semicircle, this is a rectangle, and then this is a boat made of a semicircle, a rectangle, a triangle for a sail. Yeah, it's kind of like that. These AI models learn to recognize triangles and semicircles and rectangles. It's a bit more advanced than that, but they recognize these different bits of an image and they know that certain combinations are certain things. And so image classification is just simply, is it a bear or is it not a bear? Object detection is a bit more advanced. Object detection is about detecting objects in the image. So the idea is you have, it'll actually look all across the image and say, there is a bear in this particular area. So in this box, there is a bear, or in this box, there is a bear. And that, you can actually use this to count objects as well. So it's not just bear, not bear. You can actually use it to count objects. So if instead of saying this is a bear, there's a bear here, bear there, I've got 3 bears, things like that. Kind of a bit more accurate than image classification, because your image classification may not recognize 2 bears as a bear. This one will recognize both. So that's kind of things you can do with vision-based AI. So I could use this to detect bears in my back garden. So I could train models to detect bears and use this. Now with AI, if you've not done any AI, essentially there's 2 stages for AI. You have training, where you teach the model, and then you have inference, which is where you use the model on new data. So you start off with Vision AI, you maybe start off with what's called labeled data. So you have a whole lot of pictures, and you would say to the AI, these are bears. Here is a whole lot of pictures of bears. And then here's a whole lot of pictures of llamas or raccoons, or kind of whatever you wanted to do. You would say, here is the data. This is labeled data. These are bears. Go off and learn. And the AI would then go off and learn how to do things. And this learning takes a lot of compute power. So it's a long time to kind of learn how to learn the model, to learn how to classify or detect these objects. And that kind of use a lot of power. And then once that's done, that spits out a model. Okay. And then you can take that model and then you can use that on new data to say whether or not there's a bear in there. So train it up, give it 1,000 pictures of bears, say, go off and learn, get a model back, give it a new picture, and the model can say bear, not bear. And that's kind of the 2 parts of using AI modeling. You train it takes a lot of power, and then you inference, which uses a bit less compute power. Now, traditionally, AI has been all about big, powerful hardware. So GPUs were kind of the thing that really kickstarted the AI revolution. We see AI's been around for 60, 70, 80 years. But it's really in the last 20 years, we've kind of seen a kickstart with AI. And a lot of this is around the GPU, graphics processing unit. I know it sounds daft, graphics processing for AI, but GPUs are what powers a lot of AI. So if you think about a game, you're playing, say, Quake, for example. This is going back some for the oldies, and playing a game like Quake, you used to be able to get a GPU, your graphics card, like a Voodoo 3D-FX or something like that. And these graphics cards had specialized processors in them designed to do floating point maths. So they're very, very, very fast at doing floating point maths. Not general purpose, not like the CPU that runs your computer. These GPUs were good at doing floating point math, and that was what was needed to render 3D scenes really, really quickly. Now, it turns out for AI, what most AI is floating point maths. And so the accelerators you can get to do the maths for 3D graphics also works for AI. And so you get these really powerful GPUs that train AI models. One of the biggest companies in the world today for AI hardware is NVIDIA. Now, go back 10 years, NVIDIA made the graphics cards that go in your PC. I mean, they still do. You can buy a really powerful NVIDIA graphics card and you get Fortnite running at bajillion frames a second, or you can use that graphics card for training AI models. And there's been incremental advances on this. So you may hear TPUs or NPUs, tensor processing units, neural processing units. So these are more specialized GPUs that are designed for AI processing rather than graphics. And this is really powerful hardware. These GPUs typically draw between 200 to 500 watts of power. So they eat a lot of power. It's really powerful hardware. And this is great for training. When you're training your model, you don't train continuously. You train once and then use the model continuously. And so you want to throw all the hardware at training. You want to kind of throw all the things, throw all this power at training to train your model. But this is not so good for kind of inferencing because of the amount of power this needs. So if you want to use this to actually run your model, it draws a lot of power. Also, thinking as like a cloud, from a cloud perspective, rather than have all this hardware in your home, you don't want like a whole rack of GPUs at home. You want to use the cloud to train your models. And cloud compute is expensive. So it's fine to pay for the cloud when you're training your model. But if you're running a model, if I've got a camera set up and I want to detect for bears all the time, I don't want to pay for the cloud continuously to detect bears. Yes, I work for Microsoft. Please, everyone pay for the cloud all the time. But I don't want to pay for it all the time to detect bears. I want to do things at home, on a much kind of cheaper way of doing things. So how can we do it cheaper? How can we run this at home without needing all the power? And this is where TinyML comes in. TinyML is a fairly new thing. It's been around for a few years, but it's a fairly new idea. The idea of TinyML is you train your model up in the cloud on the really big, powerful hardware, but then you run it, do the inference on a small device. When I say a small device, I don't mean like a desktop computer. I mean a phone or even a microcontroller. So the idea is TinyML is taking your models, tuning them up, shrinking them down so they can run on highly constrained devices. And the kind of first was maybe these things running on mobile phones, taking advantage of like CoreML on iOS devices, for example, or TensorFlow Lite on Android running on mobile phones. But now it's got even smaller, even smaller. In fact, you probably all use TinyML every day and you don't realize it. So when you say, okay, Google or Alexa, that's actually running a TinyML model. Your Alexa is not continuously running a whole lot of CPU all the time, monitoring the microphone just to see whether you say Alexa. It is not continuously connected to the cloud, streaming everything you say up to the cloud, looking for the word Alexa. Instead, it's running TinyML. It's got essentially what's called a wake word model, an AI model that's designed to listen for a particular word and sound, and it runs that in the lowest power way possible to kind of keep the power consumption down. Mobile phones are a classic example of this. Pick up an Android phone and say, okay, Google. Your phone wakes up, ready to do something. That okay, Google model, the AI model to do that, is less than 20 kilobytes in size. And it draws literally microwatts of power. You don't want your phone battery to die because you spend all day just listening, just in case you say, okay, Google. So okay, Google's one of the most famous ones. So 20 kilobytes in size, the model. And this is what TinyML is. It's taking very constrained models, very small models, very low power models to run on low power devices. You kind of lose some abilities. You kind of lose accuracy as you get smaller, but you gain in the low power use. So like the wake word model can identify one wake word. It can't work out everything you say to full text to speech. That needs a bigger model. But if you just need to say, okay, Google, it can identify that. And we can do the same with image models. We could shrink down an image model that can detect a bear. It won't give us full image understanding, like those automatic alt text generators, but it can detect a bear. So we can actually run an image model on small devices like microcontrollers. And just comparing the power, on a GPU, 200, 300, 500 watts of power just to run your model, that's a lot. Microcontroller, milliwatts, microwatts, even sometimes nanowatts of power to run these models potentially. And because of this, you can actually run on battery power or USB power. You can actually have a microcontroller that can run for multiple years on a coin cell battery running an AI model, all built using TinyML, which just it's just mind-blowing that you can do this. You can create AI models that run in a few kilobytes, a few hundred kilobytes, and draws hardly any power, which is so cool. So let's build a bear detector. Let's actually build a bear detector. So the bear detector that I've been building, it's based around a few different components. So on the hardware side, I have gone down the NVIDIA route simply because I have some cool hardware that I wanted to play with. It's an ARM64 based Linux device called the Jetson Nano. I'm actually using the Recomputer version from Seed Studios, which is the Jetson Nano is like a small compute module. The Recomputer is like a carrier board that it sits on. It's great for doing AI accelerated workloads. Can be powered by USB. So USB power, 5 volts, doesn't draw much power. The stuff I'm doing today, I could run on much smaller hardware. I'm just doing it on the Recomputer, the Jetson Nano Recomputer, because I got one and I want to play with it. Software-wise, we're going to use a thing called Edge Impulse, which is an online tiny machine learning training tool. Absolutely fantastic tool. This is what we're going to use to train up my bear detector model. And then I'm going to use Azure IoT Central, which is a Microsoft online IoT software as a service platform to show all the data. So that's all the gumph. that's all the boring bit. Should we do a demo? Should we just dive in and actually build this stuff and just make it happen? Let's do it. So let's start by looking at the hardware. This here is my NVIDIA Jetson Nano recomputer. So this device, it's in a big plastic box. Let's pop the box open. There's a little button I press. Very fiddly, it's kind of a magnetically sealed box. But inside here, that is the Jetson Nano. So the Jetson Nano is literally this board here. Kind of see, don't know if you can see, there's like a little connector there. Heat sink, and then below it is a carrier board that's got all the connections. And the idea is the Jetson Nano is it's a compute module. You can just drop it in anything, use it for different uses, and then different carrier boards depending on what you need. So that's in there. And Seed provide this lovely little box, magnetic clip top, and I've got a webcam connected to it. Now, the Jetson Nano also supports, well, a lot of the carrier boards also support the Raspberry Pi camera. So I can use a full USB webcam or Raspberry Pi camera, depending on what I need. So that's kind of the hardware setup I've got. I'll show you where are we? Here's the Seed page for it. It's a $200 bit of hardware. You can get smaller options. The Jetson Nano board itself can be about 50, 60 bucks. All depends on the carrier board that you've got. So this carrier board has actually got some flash memory built in and all the connectors and all the other different bits and pieces on there. It's a fairly powerful device. I can use it to run TinyML models, bigger models. It's just quite a cool little device. So this is the tool I'm going to use for doing everything. Now, for my own safety, I don't have a bear here. So I have to train using bears. And it's kind of very hard to get a bear to sit still and do what I need. So this is the bear I'm going to be using today. This bear is a little bit less scary. Yeah, as Paul was saying earlier, I'm practically in Canada, so I might as well use a polar bear. But this is a little bit less scary. This is the bear I'm going to be using for training my model. Now, if you've done any AI before, you'll know that you do need to have good training data. And getting a bear to play ball is sometimes a bit hard. So yeah, using a model for now is what I need. And to actually kind of roll this out permanently, I would need to set up just a continuous camera, record a whole lot of bear data, and use that to train my model. That's my hardware. And so software-wise, I'm using Edge Impulse. So Edge Impulse, it's a startup, been around a couple of years, founded by someone from Hackster, someone from ARM. And the idea is this is an online training tool for TinyML models. In fact, what I'll do, let me just get the link for that shared for you. But Edge Impulse is great. And the idea is this does everything for you. So you don't have to build your own notebooks. You don't have to write your own code. Edge Impulse does everything for you in the cloud. And then you can just take models that it's built and use this. So what I can do, let's just log in. Let's create a new project. Now, Edge Impulse is currently free for developers who are just kind of playing. You want to actually do stuff. So as a developer, I can get jobs that would take no more than 20 minutes to run, up to 4 gigabytes or 4 hours of data, and then kind of a small amount of collaboration for free. And then if I want to go full enterprise, I could pay all the extra and have a full enterprise setup that does lots of things. But I call this Jim's Bear Detector. And here with Edge Impulse, I can actually choose the kind of data that I want to bring in. And what's great is this works with a whole lot of different types of data. So kind of the classic ones for TinyML would be accelerometer data. So this is things like moving, detecting gestures. So if you think you've got like a Fitbit and it can tell when you're running or swimming or rowing, that's all kind of based off using accelerometer data with tiny machine learning models. So when your Apple Watch recognizes that you're on a treadmill, that's using accelerometer data with a tiny machine learning model. I can do audio. So this is great for wake word or detecting audible events. There's some work being done, for example, in Africa to listen for gunshots. So if you've got an area that's got a high level of poaching, if you can put microphones around that detect gunshots, then you can use that information to go and stop the poachers. So kind of things like that. A very, very dangerous thing, this whole listening for gunshots thing, unfortunately. Depressingly, there's people here in the US who use this as, they're using very flawed models that are terrible at detecting gunshots to essentially harass people and use this as probable cause to go and break into people's houses. So there's a lot of terrible use cases for this. Edge Impulse do have a responsible AI principle here. So using it for gunshots for poaching is a great use case for this. Using it for gunshots to allow police to be to do things they shouldn't be doing, very bad idea. But yeah, so you can do audio things. Images, this is what we're going to be doing. So this is detecting things like bears. We also use it to do things like production lines. If you've got a manufacturing line and you want to check the quality of everything coming through the manufacturing line, you can do that. Or they support something else. Literally, it doesn't matter what the sensor is. It can take data and train a model. You just need to, if it's a sensor it doesn't know, you just need to kind of tell it how to handle that sensor. So I know what I'm doing, so we'll ignore that. So the first thing we'll do is we want to connect your device. And what's really cool is Edge Impulse allows you to gather data from your actual hardware. So the device you're going to be using to run the model can also be used to capture the data. So if you've got a microcontroller, you can literally download firmware onto your microcontroller, run that firmware, and then with your microcontroller, do the thing. So point the camera at the thing or make the noise or create the movement that you want to do, and that will stream the data from your microcontroller and your sensor up to the cloud. So you're actually getting your data from the actual device as kind of as close as possible to reality. For the Jetson Nano, this is a Linux-based computer. And so I can actually run their CLI from the Linux computer and use that to stream data in. So what I can do is I can go in. Now I'm going to flip between a couple of projects because I don't want to do too much setup, but essentially I've got one already set up here, the project I've already got, and I'll show you me connecting my Jetson. So if I go to my terminal, I'll just SSH into my Jetson Nano. So I'm connected, and then there's the CLI that I've installed. I just run this. I'm going to disable the microphone because I'm just capturing audio data. Sorry, video data. And what this will do, this will connect to my camera. It knows I've got one camera. It detects all the cameras that I've got. So you see it's connected to my Logitech webcam C930E, connected to the camera, connected to Edge Impulse, and connected to my project. And so you see my device is connected. If I go to the data acquisition, here is a live feed from my device. So it's picked up the camera. And here's my bear. Hello. And I can use this for training. So I don't have to write any code. This is all done through the UI. So if I want to capture this, I can just say start sampling. That's captured this picture. Let's move the bear a little bit. Maybe move my hand out of the way. Bit of a close up. And I can just go through and just click and capture bear images. And this becomes my training data. Now I want to do object detection. And so what I can do with these images is I can then draw a box around the image. So I can go here and say, right, this bit here, that is a bear. Set the label. That's a bear. Save that. Brings up the next image. The bear's in the same position. Bear. Save that. This one's not a bear. Let's delete this sample because there's no bear in that one. Here we go. Here's another one. Again, draw a box around the bear. And this is kind of the boring part of object detection, is the labeling side of it. So you have to kind of go through and label all your data. This is kind of a great use of things like Amazon Mechanical Turk, where you pay people by the minute to do this kind of stuff for you. There we go. Yeah, I've already got a lot of data captured, which is why you don't want to see me do this for like 100 different images. It's very, very dull. So that's labeled. So that's got my training data. It's data. It's labeled. I've got a whole load of data here. And then what you want to do, you need to split your data. So when you're training an AI model, you have your labeled data that is used to train the model. Then you also need test data that's kind of used to continuously check the model as the model is being trained. And so I've got a whole lot of my data that's there. And then once I've got my data, I can then start building my model. Again, no code to write. What I do is I create what they call an impulse. So I start off with my image data. This is my data that's coming in. So it'd be my training data or the image from my camera for my final data. And I choose the size that I want. Now, when you do any kind of vision-based AI, you use a neural network. The neural network is basically a collection of inputs where you put a value into it and then takes the value and sends that to another so it's inputs, basically it's tripping over words. You've got what's called neurons, and the inputs go into these neurons, and these neurons do something to the value that comes in, sends it to another neuron, and as it sends it, it may filter it out or change things or do kind of various maths across it. And so each neural network has to have the same number of neurons, which means you have to have the same number of inputs. So all images have to be exactly the same size, and every pixel in the image becomes an input into the neural network. So you can't put a 100 by 100 picture and a 400 by 400 picture into the same neural network. There's just not enough input neurons to do both. So what you always do is you resize your images to a standard size. And as it turns out, the smaller can be better. If you have too high a resolution image that you're analyzing, your model can actually get far too specialized. For example, if you were to train a model on some really close-up pictures of, say, a wooden boat, and then give it a nice kind of lots of wood, maybe 3 masts, really sharp image of that, train on that, then give it like a painted white single mast boat, the neural network goes, that's not what I've been trained on. I've been training these wooden boats. Whereas if you give it low resolution boat images, it goes, yeah, that's kind of boaty. That's the thing. So it kind of works with low resolution images. 96 by 96 seems to work pretty well. You don't want to go really high because you could just kind of, it's amazing how much accuracy you lose out. And then you have to work out how to fit that, because most images are rectangles. You get your phone out, take a picture, portrait, it's a rectangle that way, landscape, rectangle that way. So you've got to kind of shrink these images down to fit. And so you work out whether what you want to do to crop. And so I'm fitting it based off the shortest axis, so it kind of cuts it down. So yeah, that gives us our input image. Then we just have an image processing block to do things to the image, to work out what we need to do with the image. We then add our actual machine learning model, which in this case is object detection. And then we have our output, which is whether it's a bear or not a bear. And so we kind of build up this flow of image data comes in, we do image processing to kind of get the image where we want it to be, to train our model, and then spit out the bear. And then from here, I go to my image, and I have to do what's called generate features. So this is the bit that goes through the image and pulls out different parts of the image. I was saying earlier, think of it like with a sailboat, you have like a semicircle and a rectangle and a triangle. This is the bit that learns how to detect semicircles, rectangles, and triangles. Obviously, a lot more advanced than that, but this kind of picks out the different bits of the image. And this just sits there, runs in the cloud, and gets the features. And what's really cool with Edge Impulse is it gives you the suggested performance of doing this on the device. So I've got, when my model runs in training, it needs to pull out features. But when my model does the inference, takes a new image and determines whether there's a bear in there, it has to generate the features again. And this tells me that on my device, on my Jetson Nano, it'll take 1 millisecond to run and use 4 kilobytes of RAM to do this particular activity. So take an image, pull out the features, 4 kilobytes of RAM. And this is really important information. If I was running this on a constrained microcontroller, I'd want to know how much RAM this would use and how long it would take. Because I may have requirements such as I've only got 256 kilobytes of RAM, so I need to know how much RAM is being used. Or maybe time is important to me. Maybe my conveyor belt moves so quickly, I need to process each image in less than 20 milliseconds. or 100 milliseconds or whatever I need. And so I need to make sure I've got my processing time. So this is really useful information to help you with your model. Then once I've got my features, I can train my object detection model. And there's multiple different types of object detection model that you can use. So kind of the classic one is MobileNet or ResNet, and these ones have full bounding boxes. So kind of a MobileNet, kind of a classic object detection model, and it detects the objects and it gives you a bounding box. So it actually gives you this idea of here is the thing, here is the bounding box. It starts at this location on the image and it is this size, and you can see exactly where the image is. Now this is great, but it's actually quite an expensive model to run. And Edge Impulse have come up with a new model called FOMO. Faster objects, more objects. And FOMO uses a thing called centroids. And the idea of this is it can't give you the exact bounding box. It can't say, you know, this is the bear here in this box. It just says the center of the object is here. So you don't see how large the object is, you just see where the center of the object is. And this is substantially faster. It's like 30 times faster than MobileNet, using a lot less memory usage. In fact, what is the where's the link to the? Well, there's a link to the docs on here. I was going to try and just do the comparison. Edge Impulse FOMO. Where's the? Someone here that actually document the comparison with MobileNet and just how much faster it is. Yeah, 30 times less processing power and memory than MobileNet or YOLO v5. So this is a really, really fast model. And I say it detects what's called centroids. So it doesn't tell you this, yeah, this is a bottle, this is a can, it just shows you the middle section. So traditionally, object detection would be face is here. FOMO does it. I don't think I've got the equivalent picture of that, but FOMO just basically says, no, face is there, puts a circle in the middle. But much more efficient. You're 30 times less processing power and memory than a classic MobileNet or YOLO. So I can train this model, and this is a fast model. Then here I can put in, I can tune how many training cycles. There's kind of a point at which more training cycles is better, and then it kind of just drops off. And so I can kind of keep tweaking this and rerunning it. I can use a validation set, which works out what percentage of images to keep for training. You run the model, test it. Is it good? No. Try again, test it, try again, test it. I can choose things like the learning rate. This determines how much it looks at the curves as how much it's learning. All stuff that I don't really understand, but I don't care about because I literally just click start training and things happen. This is one that's great about Edge Impulse is you can dive in really deep into these models and kind of learn how to really do them, or you just click the button and hope. And most of the time it just works. Yeah, you don't need to be a machine learning expert to get something that basically works. And this is going to go off and this is going to run, and it's going to take a while because it's got to do 100 of these epochs. So we'll just kind of leave that running. Now I have what's called an Aneon Tuner. Doesn't work with object detection, but they've got some tuning as well to make things run really fast on microcontrollers. So you're doing like weight world models, they can kind of tune these down really, really fast. You can kind of cut your model size down by about 50%. But let's do some let's actually show this model in use. Let's actually show this, which is a pretty cool trick. So what I can do is I can run another little thing. Where's this one here? So they have a Linux runner. And what this will do is this runs on my Jetson Nano. Oh, we're still training, are we? Okay. Almost finished training. So what the Linux runner does is actually runs your model live. So it allows me to use the camera on the Jetson Nano and actually run the model, and it streams it to a web page. So it gives me a web page that sits there, and I can see the output from my camera, and I can see the output from the model, which is very, very cool. Kind of good for this kind of live testing. Yeah, so see, Edge Impulse is kind of quite fast to get things going, so I want to be able to kind of do this live classification fairly quickly. Finished training. Slowly going through. Just gives a few more seconds to to finish off all its bits and pieces. So once it's finished training, let's train the model. These models are quite large. It then needs to kind of shrink the model down. And so these models, these neural networks, are based off maths. You have neurons that do mathematical transformations on numbers. They send data somewhere else and do mathematical transformations on it. And these are normally large numbers, like 32-bit floating point numbers. And you can shrink these down by changing the type of number. So, for example, instead of using 32-bit floating point number, you can shrink everything down to use an 8-bit number. And suddenly your model is a quarter of the size. A little bit loss of accuracy, but quarter of the size. And these are the kind of tricks that are done to make the model smaller. And so here we have in our quantized INT8. So just taking a model and shrinking it down to just use 8-bit numbers for our neural network gives us a bear detection, 100% accuracy on the background, 100% accuracy on the bear. So it's saying our model is really, really good. And here's our data again. It takes 171 milliseconds to run the model using 243.9 kilobytes of RAM, and the model stores in 77.5 kilobytes of flash storage. So if I've got 128 kilobytes of flash, it'll fit. As long as I've got enough RAM to run this, plus everything else, there'd be 512 kilobytes of RAM. I can run this model, which is pretty cool. Seeing a question here from Anthony. It says, what format is the model in? Text, JSON, YAML, or binary? The model is a binary format. They have different ways to export the model depending on the type of model. If I'm doing like a simple weight word model, then it'll spit it out like TensorFlow. If I'm doing it, FOMO, they've kind of got their own format for everything. But they have different tools for kind of running the model, which we'll come to in a minute. It's not designed to give you a model that you would then take and do your own thing with. It's designed to give you a model that you would then take and use their code to run it, because they've kind of optimized everything for you. So I'll be showing all that in just a little bit. But great question. But now I've got a model going. Let's actually try this again. Let's run a live runner. Which will start up, and then this will download the model. Just prep a whole lot of stuff in the cloud. And what it's doing now is it's actually compiling an application. So it's taking the model from the cloud, and then it's compiling a C application to run locally to actually run the classifier, because everything's based off C code. And so if I actually go to my Jetson Nano on here, you will see here's the live feed from my camera with my bear here, and you'll see there's the centroid. So it's not perfect because it's a very small model, but it's pretty good. And it's showing, there you go, that's the center of the model. And it's actually running a lot faster than it thought. So it makes guesses as the inference time. So if you see, reckon 171 milliseconds, that's kind of a guess. Actually, what this is getting here, between 3 and 10 milliseconds on the inferencing. So it's fast, and it's detecting my bear. You notice it's black and white as well. Again, this comes down to kind of shrinking the data that you use to make the neural network smaller. To do this in full color, you've got to have 3 channels of data. You've got to have the red, the green, and the blue. That's obviously 3 bytes of data. To do it in black and white, it's 1 byte, which means it's a lot smaller. To do 100 by 100, that's 10,000 neurons to get 100 by 100 pixels by 100 pixels, each taking 1 byte of data in there. If it's full color, that would be 30,000 neurons, so it'd be much bigger. So do it in black and white because it's easier, because it's substantially smaller. So that's pretty cool. I mean, literally, I pretty much did everything live apart from label some of the data. In terms of the amount of data I've got, wrong one. In terms of the data I've got, I have got 33 images. So it's not much. It's not a huge amount of data. Obviously, the more data you have, the better your model becomes. But I've only got 33 bits of data. So you can go through and you can do this yourself in less than an hour. Doesn't take very long. It's just a bit boring drawing the boxes around. So another great question from Rebecca saying, is the number in brackets the probability? If so, why is it constantly changing on a static video feed? Great question. Yes, that is the probability. So AI models always work off, machine learning models work off probability. So it'll run something through and then the model comes up with a probability that it matches a particular label. It's never kind of a 1-0 binary type thing. It's always a probability. The reason why it's constantly changing is, I don't even notice, but the image is also very subtly changing. And so just where the input from the camera gets compressed, you know, and there's just subtle movement because I'm moving around, so the image is changing. And then you'll notice I've got lights flashing. If you look at the lights above me, you'll see the lights are flashing. And so the input is constantly changing. So it's constantly running the model. And so because there's always these subtle changes, they're going to get slight differences. Yeah, if I were to turn these lights off and sit perfectly still, then it should be static. Or if I were to move, if I were to move out the picture, in fact, let's move out the picture. Let's turn my lights off. You see that's a lot more stable. It's kind of 89 to, yeah, see, there's just very subtle changes in the image as it's compressed. So a bit more stable. And then as I come into the image, you'll see it kind of zips around a lot more. So yeah, great question. Great question. Obviously, yeah, if it was a really high resolution image with no artifacts, it would stay stable. If I put the exact same image in every time, it would stay stable. But yeah, I can then use this, obviously this number here, this is the % chance that it thinks it's a bear. I can then use this to kind of guide whatever application I build. Yeah, if it doesn't detect a bear, this is not there. But I could, yeah, if I found that there was, ooh, there you go. If I move my arm there, oh, there's a 50% chance this is a bear because it's worked out something from the shape. But then I could say, well, actually, I only care if the bear number is in the 90s, you know, or I can kind of put some kind of threshold on this percentage to kind of determine whether or not I agree that's a bear or not. So that's using Linux Runner, great way to test out your model. And then now what I can do, I can think about using my model. So I could version it. I can actually take a copy of a version, you know, same as putting stuff in source code control. Track this as a version, create this version, and yeah, allow me to kind of roll back and forward with my different models, and then I can deploy it. And this kind of goes back a bit to Anthony's question of how can you do it. So I can deploy it, and I can deploy it in a number of different ways. So I can download a binary, for example. So this is the Espressive ESP-I. This is a ESP32 with a camera built in, and I can actually download binary firmware for this that will run this and then spit out through the serial over serial whether it detects a bear or not. So I can literally download a binary that I could use for this, and that's got everything just pre-built. I just download the binary, copy it on, done. I can download a version to run on my computer if I want to, on my phone, or I can download kind of raw code. So I get the raw C++ code, and yeah, I can then use this. And so this will actually have the model as binary data embedded in C++ code. So if I actually, let me just download and have a look, actually. Click on that and then click build. This will start to create it as C++ code. We can have a quick look at that. There you go, it's downloading. And then if I can put downloads, bear detector, unzip that, open it in VS Code. What I've got here, this is a TF Lite model. So this is this is designed for TensorFlow Lite, and this is the actual model. It's got a header file with load declarations, and this CPP file. This is enormous because this has actually got the TensorFlow model as raw data. So all the bits in here as literally raw binary data. When this compiles, obviously it'll just compile it down to very small, but this is the raw data in C++ format. And then I've got the Edge Impulse SDK that runs it, and then my model parameters. So that sets up the model. So this is a library. I can then use this library, compile this up, and use this in any C application. And there's loads of other formats that I can use for this. So I can spit out as an Arduino library. So if I'm using Arduino, I can spit out as an Arduino library. STM Cube, I've got that for there. WebAssembly. So if you want to run this using, I think it uses TensorFlow.js. Let's have a look. Let's build the WebAssembly version. But I can then run this under WebAssembly on my inside a web browser. So if I want to have a bear detector using my webcam, wait for bear around, I could get that. I could use it from there. TensorRT. So if I want to run things fast using the GPU of a Jetson Nano, I can do that. And then the EthosU neural processing unit, OpenMV. So a few different formats. They're slowly expanding this. And what's cool as well is there's loads of kind of open source versions of this where you can take the code and run it on different types of hardware. So the question from Paul is, what happens if I hold a raccoon up to the camera? Can it distinguish between Azure Bit and your bear? Great question. Let's try it. So that's the bear. That's Bit. There we go. It can distinguish. Let's move a bit more into view. So it's having a bit of trouble when there's different things in the background. But yeah, it can distinguish. And so what this is kind of showing me, because there's kind of trouble with different things in the background, more of that way, then I need to kind of improve my training data a bit. So I could then take this and say, okay, let's capture some images with Bit in it as well, and then use that to retrain. Same as it kind of picks up.
I'm quite impressed with that, Jim, because you've had to do no training to say this is not a bear. This is it's gone straight to it.
Yeah, and there's definitely this issue where it's picking up part of my arm as a bear. I guess I have bare arms, so sorry. But I could then take this data and say no, take pictures with my arm here and just mark the bear, not my arm. And so I'm kind of use this live runner to kind of get this idea of what works and what doesn't work, which is pretty cool. And then obviously I can take this and train it on a raccoon. I'm not just limited to just training on a bear. I can have multiple labels. So I could train this on a bear, on a raccoon, on a deer, on a bobcat, on a coyote, and just use this to, or cougar, whatever kind of animals we can get around here, and use to identify a whole lot of different types of animals, which is very, very cool. So now, I've got this model. Oh, we can look at the WebAssembly, won't we? I was curious what the WebAssembly was. So the WebAssembly one is, there you go, Node.js stuff. So actually run this WebAssembly file, we can run it in Node.js. So Rebecca asked the question, is there a benefit to training this is not a bear? Nope, not with object detection. It's designed to detect specific objects. There's no kind of upside to training that. But in terms of other formats to export, I can actually export this as a Python library. So as well, if I don't want to do C++, I want to do a Python library, I can actually export this as a Python library. And so I can just say, so we've got a little command here we run, and that downloads the model as an EIM. So going back to Anthony's question, the format, this is kind of a proprietary format for doing it. And once I've downloaded this model, I can then run this through Python. And they have a Python SDK that I can run that knows how to talk to my camera and would do everything for me. So I can say, I take my model file, I launch it through their runner, and then I say, give me frames. And this runner, the actual code that Edge Impulse provided, knows how to talk to my camera. It uses OpenCV, and you can have multiple cameras attached. You tell it which camera you want. In my case, I've got one, camera 0. It'll give me that, and then it will spit out in Python code the cropped image, so I can kind of see the image that's there, and it will spit out the various bounding boxes for the bear. So if I just run this, JPEG there. Let's just give it a second to run. You'll see it's detected a bear. And if I take the bear away, Give it a few seconds because I've put a timer on there. No bear detected. Put the bear back. Bear detected. And so a little bit of Python code detecting bears. And then I'm a big fan of using Python to connect to Azure IoT Central. And so from here, I'm just sending this up to Azure IoT Central. Got a little bit of Python code to do that. I would do this all in C, but I really couldn't be bothered to use the C SDK to talk to IoT Central. It's kind of a little bit hard. There's a lot of work. I just do it in Python, a few lines of Python, and then suddenly I have got up here a list of my bear detections. So this tells me when the bear was detected, when it came, and when it went. So just a simple list of true or falses to detected, but this can show me when the bear comes and when the bear goes. So I can now take this, put this outside, and if a polar bear ever comes into my back garden, I can see from this dashboard how.
So, Jim, is it true to say that Edge Impulse has done all the work for you there?
Yes, absolutely. They've done absolutely everything. I mean,
fair.
literally, the only work I had to do was drawing the boxes. Everything else is in here. I didn't need to deeply understand how all the bits work. They literally have guides that say, do this, do this, do this. And so it does all the work. And without me having to do much tuning, it's a pretty impressively good model. Obviously, over time, if I could have more data, I could tweak it maybe. If the object detection model, when it comes to this, maybe I want to change my number of training cycles or adjust my learning rate and all that kind of stuff. But really, I just, accept the defaults, start training, and out I get is a model, and I can use this. Edge Impulse is brilliant for this. It does all the hard work for me. So yeah, that is my bear detector.
Jim, that was excellent. Thanks very much. I really enjoyed that. Learned a fair whack on that. I do spend a lot of time with Vision AI. But in regards to the deployment and stuff that Edge Impulse have done here, that's really, really impressive.
Yeah, they want to make it easy. There's a lot of IoT is hard. So I keep saying that I think the future of IoT is going to be things just getting easier. Yes, a lot of IoT stuff is just so hard. Getting the right library, the right tooling, the right sensors, the right connections, all this kind of thing is really difficult. The future is getting it easier. You think about going back 25, 30 years when we used to just write desktop applications. You had to kind of tune your autoexec.bat and EMM386.sys, whatever, and then so much just to write a desktop application. Now it's easy. I see the same with IoT. We want to get away from all the hard stuff, have a lot of that just dealt with for us, and we just say, "I want the thing," and it spits it out. So this is kind of the future. Answer an interesting question. Can I download different models on demand, e.g. into a multi-platform app with a video stream from Unity AR camera to let them point the coordinates in the Unity AR model? When you say different, I'm not sure what it's going to mean by different models. But I mean, once you download the model, obviously you can do what you want with it. So if you've downloaded a raw C library, you can use that. So if you wanted to use it in Kotlin, for example, you could just compile this to a C library, call through to that C library, and then take the stream from the camera, and then you want to use the model in a Unity app. Again, you can just library, wrap that up in, and just call that from Unity. But you can export all the different formats if you want. The Python one that I exported is exactly the same model as I could get with a C++ library or WebAssembly. And so I can export it in any I want to use this. Now, in terms of doing it on demand, so if I had a way where I was going to retrain and actually download things on demand as I need it, I don't know how all the APIs are for this. They do have an API for accessing Edge Impulse. And so in theory, what you could do is you could use the API to gather data. So if you've got your app, got a video stream coming in, and you want to use that to train your model, you could, in theory, use the Edge Impulse API to kind of upload that data, label it, train the model, and then read down the model into your Unity application. So yes, you can download models as far as I understand based off their API. So deployment, down. There you go. So this is the API to download. So yes, if I understood your question correctly, yes, you can use it in all, you can same model in all different formats and different parts of the application, but then use that to retrain more data. Hopefully that answers your question, Anthony.
Thanks, Jim. I was just about to say, I agree with you, and we've talked about this a few times on previous shows, that, you know, the real scale and adoption of IoT is when it becomes easier and easier to actually start to make it. You know, tools that have the user in loop, subject matter experts that actually can start to configure this. It's almost like the WordPress, isn't it? Kind of experience that, you know, when you enable it for a regular Joe to be able to start to plug things together, connect things in a simple and easy way, is when things will really, really grow and scale with it. John, do you have any questions? I am 5 minutes late for a meeting, but do you have any questions for Jim? You're on mute, mate.
Doing the presentation. So yeah, fantastic.
I really enjoyed that, Jim. I'd love to have you along again and have some more insight from you. That was really, really entertaining and really interesting as well. And I do need to catch up with you outside of IoT North with some stuff that I'm working on at the moment that you might find interesting. But on that note, thanks very much for joining us, John. August, we're
both on holiday, so we're closed. But we'll be back in September with an action-packed program.
Maybe by yourself. I'll be in the Maldives. My holiday has been shifted.
Okay.
But we'll get something organized for that period. But thanks very much. If you'd like to catch up with any previous shows, iotnorth.uk/events. We've got nearly 2 years worth of content on there, I think. So do check that out. And if we can help you in any way, if you'd like any insight, by all means do get in touch. We're always here to help and guide. Anthony just shared fabulous presentation. Thanks, and full-heartedly agree. Thanks for that. Good evening, good afternoon, Jim, and goodbye.